All right, let's get into it. Today, we're putting on our detective hats. We're not just building regression models, we're putting them under the interrogation lamp. Our mission? To figure out if they're telling us the truth or just spinning a good yarn. Let's start the investigation.
So you've done all the hard work. You've collected the data, you've cleaned it up, and finally, you've built your model. It spits out a result, but here's the million-dollar question. Can you actually trust it? Is it really explaining what's going on, or is it just a convincing story? That's what we're here to figure out.
Every model is basically telling you a story, right? It looks at all this data and tries to find a pattern, a narrative. Our job as the detectives is to gather the evidence and see if that story actually holds up when we start asking the tough questions.
Okay, so where does any good investigation start? With the first clue, of course. And in the world of model evaluation, that first, most obvious clue is almost always a little something called R-squared.
So what the heck is R-squared? Well, think of it this way. It tells you how much of the mystery your model actually solves. If you're trying to figure out what drives portfolio returns, an R-squared of, say, 70% means your model's variables can explain about 70% of why those returns move around. It's our first crucial piece of evidence. And here we have it, out in the wild, our first piece of evidence from the crime scene. The R-squared is 0.6155. So, in our detective story, this means our current lineup of suspects, our variables, can explain about 61.5% of the case. Hey, not a bad start, right? But wait, just like in any good detective flick, there's a plot twist. That first clue, our trusty R-squared, well, sometimes it can be a little too optimistic. It can send us chasing false leads. And here's the catch. R-squared has one major weakness. It's a sucker for complexity. You can throw another variable into the mix, any variable at all, and R-squared will almost always go up. This happens even if that new variable is totally useless. Okay, let's see this trap in action. Imagine we start with a solid model, 3 variables, and we get an R-squared of 61.5%. Pretty decent. Now, let's throw in a 4th variable. Who knows if it's any good, but what happens? Bam! R-squared creeps up to 61.8%. See? It looks like our model is getting smarter. Why stop there? Let's add a 5th one. And, yep, you guessed it. R-squared inches up again, this time to 61.9%. The number is going up, so we must be doing something right, right? And this is where we need to stop and really think. Just because that number is getting bigger, are we actually getting any closer to the truth? Or are we just muddying the waters? This is where we call in the expert. Enter adjusted R-squared. It's the grizzled veteran detective in this story. It's way smarter and more skeptical. It sees right through that little trick and actually penalizes the model for adding junk variables that don't really help. And this chart, wow, it shows it all perfectly. Just follow the blue bars. That's your basic R-squared. It just keeps going up and up as we add more factors. But now look at the gray bars. That's our smart detective, adjusted R-squared. See how it goes up? But then when we add that 5th factor, it actually drops. That's adjusted R-squared telling us, nope, that last suspect is a red herring. Get him out of here. All right, so what happens when you have multiple theories, multiple models, all vying for your attention? Well, it's time for a police lineup. And to run this lineup, we've got 2 specialists, AIC and BIC. Think of AIC as the profiler, trying to figure out which model will be the best at predicting what happens next. BIC is more of the hard-nosed detective, looking for the simplest, cleanest explanation for the evidence we have right now. But for both of them, the goal is the same. The lowest score wins. Okay, here's the lineup. We've got 5 models on display. Now, you can forget R-squared for a second. Just focus your eyes on those last 2 columns, AIC and BIC. We're on the hunt for the lowest number. And there it is. See it? That 4th row. The model with 4 factors, it has the lowest score on both counts. The evidence is pretty darn clear. The model with those 4 factors has the lowest AIC and the lowest BIC. What that's telling us is that it hits the sweet spot. It's got great predictive power, but it's not overly complicated. We've found our prime suspect. But we're not done yet. We've picked our best model, but a good detective interrogates everyone. Now we need to put each individual variable, each suspect, inside that model on the stand. We do this with something called a hypothesis test. Sounds fancy, but it's really just a 3-step interrogation.
Step 1, we state the charge. Is this variable actually involved, or is its impact basically zero? Step 2, we check the evidence. That's the p-value. And step 3, we reach a verdict. If that p-value is super low, usually less than 0.05, then the evidence is overwhelming. Guilty. The variable is significant.
Okay, let's open the evidence locker. That p-value column is where the action is. Look at factors 1 through 4, tiny p-values, basically zero. Guilty, 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 guilty. The evidence is solid. But now, look at factor 5, a p-value of 0.75. I mean, that is huge. There is zero evidence this guy was even at the scene of the crime. Verdict, not guilty. We're throwing this one out.
And, we can also do a group interrogation. That's what an F-test is for. It lets us check if a bunch of variables are significant as a team. It's basically like checking for accomplices to make sure the whole operation makes sense. All right, case closed. We've followed the leads, we've interrogated the suspects, and now we can deliver the final verdict. We've put together a pretty awesome toolkit for any data detective out there. And here it is, your go-to toolkit. Remember, for adjusted R-squared, you want the highest number you can get. For AIC and BIC, you're hunting for the lowest score. And for your t-tests and f-tests, you're looking for values that are big enough to cross their critical thresholds. This table right here, this is your cheat sheet. Keep it handy. So there you have it. You're not just building models anymore. You're an investigator. You've got the tools to dig deeper, to question everything, and to find out what the data is really trying to tell you. So the only question left is, what story will your next model tell?